Here we are again. Today we're beginning chapter 10 on conic sections and quadratic relations. So our introduction, our section 1 is just an introduction all about conic sections. So our objectives are to answer the question, where do conic sections get their namesake? We're going to graph the most basic forms of conic sections and identify conic sections based on those given graph, or based on given graphs. So if you think about the word conic section, the word conic, the root word it comes from is from the shape of a cone. And we're going to talk about two cones that are inverted and the shapes that they can make if you were to take sections of them. So that's why they're conic sections. So if I were to take and cut a conic section across horizontally, I would get a circle. If I were to take and
Attention elementary teachers.
If I were to take and cut that cone at an angle, I would get an oval shape, which we call an ellipse. If I were to take and cut so that it's diagonal, or not diagonal, parallel to one side of the cone, I would get a parabola, which we've done parabolas before. We're going to do a little bit more in depth. And then if I were to take and cut through two cones, I get parabolas that face different directions. We call those hyperbolas. So in this section, we're just going to take a brief look at each of these: circles, ellipses, parabolas, and the hyperbolas. And then each section in the chapter will take a little bit closer look at each one of these individually. So a conic section is a curve you get by intersecting a plane and a double cone. By changing the inclination of the plane, you can get a circle, a parabola, an ellipse, or a hyperbola, which is what I just showed you. And there's a video you can watch on YouTube that just talks about conic sections and how they're formed. So first one is a circle. So what's the graph of x squared plus y squared equals 25? What are its lines of symmetry, and what are the domain and the range? So since we don't know how to graph conic sections yet, or what their formulas mean, we can just look at this and say that a circle, you can notice, is x squared plus y squared equals a number. So you notice that the numbers in front of the x and the y are the same. They're both understood to be 1 in this case. So x squared plus y squared equals a number always makes a graph of a circle. So that's the equation of a circle. So let's pick some values. We're going to make an xy table here. So if we plug in, let's just make it easy. If we plug in 0 for x, we get 0 squared plus y squared equals 25. Well, that's just 0. So y squared equals 25. Take the square root. So y equals 5 or negative 5. If we plug in 0 for y, the same thing happens. We get x squared plus 0 squared equals 25. So x squared equals 25. So x equals 5 or negative 5. So that means we have 4 points. We have 0, 5, 0, negative 5, 5, 0, and negative 5, 0. So if we were to put these on a grid, we'd have 4 points. And what are some things you know about a circle? Well, it's a smooth curve. Hopefully you have learned that they have a center. They have a radius that's equal distance from the center to every point on the circle. So what are our lines of symmetry? Well, if we look at this, the line x equals 0, or the y-axis, or if we look at the y-axis, this is, the x-axis, y equals 0. Those are both lines of symmetry. If you were to take and fold that circle over on top of itself, it would make the same image on either side. The fun thing about circles is that any line that goes through the center will make a line of symmetry, as long as it goes through the center, because circles are symmetric. So then we have to look at our domain and our range. Our domain are x values, and x is anything between -5 and 5. and y is anything between negative 5 and 5, because those were our limits. What about this one? If we were to graph x squared plus y squared, what are its lines of symmetry, and what are the domain and the range? Well, hopefully you noticed a pattern from the first one to the second one. What do you notice about the equation and our domain and range? Well, it equals 5, and the domain and range are from negative 5 to positive 5. So you take the square root of whatever that number is. So the square root of 9 is 3 and negative 3. If we have center at 0, 0, and then our lines of symmetry, we have infinite number because it's a circle, and our domain is negative 3 is less than or equal to x, which is less than or equal to 3, and our range is negative 3 is less than or equal to y, which is less than or equal to 3 as well. For an ellipse, if you look at this equation, what do you notice that's different about an ellipse than about a circle? Well, an ellipse is still where you add your x squared and your y squared value, except the coefficients in front of your x squared and your y squared are different numbers. So x squared plus y squared still makes that circular shape, except it's going to be an oval this time. So we are going to have to graph this and find its lines of symmetry. So let's do the same thing by making an xy table. If we make x be 0, then we have 16y squared equals 144. And then if you take and divide 144 by 16, you get 9. So y is 3 and negative 3. Same thing for y. If you plug in 0, x is 9x squared. Divide by 9. X squared is 16, so x is 4 and negative 4. So we have these 4 points now, 0, 3, 0, negative 3, 4, 0, and negative 4, 0. So if we were to graph this one, I have 0, 3, 0, negative 3, 4, 0, negative 4, 0. This one is more ovally shaped. It's not a perfect circle because we have from our center, still at 0, 0, we go 3 one direction, but 4 another direction. So that was an ellipse. For a hyperbola, this one is probably the most complicated, but you can definitely distinguish this one because it's x squared minus y squared equals 9. So this is the only one that has x squared and y squared with a subtraction in it. So we're going to graph this and find lines of symmetry and domain and range. So for this one, we also need to make an xy table. But this one's going to be a little bit more tricky because if we just plug in 0 for x, we get negative y squared equals 9. So y squared equals negative 9, and then we're going to get imaginary numbers. So 0 is not going to be a good one to use for this one. And you'll see why in a minute. So let's think of another value. What's something else that we could plug in? What if we did 3? So 3 squared minus y squared equals 9. Well, 3 squared is 9. Subtract 9 from both sides. Y squared equals 0. So y equals 0. So you know you have the point 3, 0. Would that be true for negative 3 as well? Well, let's try it. Negative 3 squared minus y squared equals 9. We still get, becomes positive 9. So we subtract 9 from both sides. So y is still 0. So we know we have 2 points. Now we need to think of something bigger, like 5. If we did 5, 5 squared minus y squared equals 9. 5 squared is 25. Subtract 25 from both sides. You get negative y squared equals negative 16, so we'll just make those both positive. So y squared equals 16, so y equals 4 and negative 4. So here's where we're getting into the 2 points again. So let's see, we have 3, 0. Negative 3, 0. We know we have 5, 4, and 5, negative 4. What if we did negative 5? Would the same be true if we plugged in a negative here? Well, we would still get 4 and negative 4. So we're starting to get those two parabolas facing away from each other. I would say yes. So this is our hyperbola. So now lines of symmetry. We have this one, x equals 0, because the one would fold onto the other one. And we have this one, y equals 0, because they would fold in half on top of themselves. So I hope you've noticed our lines of symmetry always go through like a central point, a point that is centered to our graphs. We didn't really talk about parabolas. We've already done parabolas this year, but just really quickly, I'm going to show you parabolas are going to be in one of two forms. So far we've talked about y equals x squared. If our value of a was positive, we said that it was happy, so it goes up. If our value of a was negative, it was sad and points down. So that's what we did first semester. Now this one, can you make a conjecture about what you think these ones are going to do? Instead of going up and down, these ones are going to go left and right. So if it's positive, it's going to go to the right. If it's negative, it's going to go to the left. So we'll learn more about conic sections in the next section. So just identifying these, I want you to tell me what are the centers and the intercepts of the conic section and the domain and range. So this is an ellipse. If you just look at it, you can see that our center is here at 0, 0. And our domain are our x values, so they go from negative 4 to 4, and our y values go from negative 2 to 2. Alright, and for this one, this hyperbola, our center is at 0, 0, you can see again. But this one, the domain and the range are a little bit different because we have this section right here where there's nothing. So our x values this way have no restrictions. So x is going to be all real numbers. But this way on our y, we have a cut here and then it picks up again here. So y is going to be everything that's greater than or equal to 1, but also y is everything less than or equal to negative 1. So hyperbolas are the only ones that have a little bit of nuance as far as graphing goes. Alright, and that's your introduction to conic sections. I hope you're excited for what we're going to learn this chapter.